Hi everyone, it's Coach Fred here, and today I'm going to be talking about multiplying and dividing rational exponents and radicals. So if you haven't watched the video on the introduction to fractional or rational exponents and radicals, please do, because you kind of need that to do this, okay? All right, so let's look at multiplying. Oops, let me get to multiplying, okay? So in order to multiply or divide radicals, they must have the same index, okay? They must have the same index. Otherwise, you can't multiply them, okay? If they do, you can multiply. If they don't, you can't. So here's an example, you can't. See, this one has an index of 3, and this one is a square root, so it has a hidden index of 2. So you'd have to leave it like that. Whereas these both have the same index, so you can multiply them, giving me the cubed root of -8, which we know would be -2, recognizing that we can take odd roots of negative numbers. All right, so multiply if possible, then simplify. All right, so here's one you're comfortable with, square roots. So I have the square root of 4 times the square root of 25, so I have two ways I could handle that. I could evaluate it first and simplify, or I could multiply then simplify. I'm looking at it and I see that it's the square root of 100, so my answer would be 10. All right, looking at number 2, you can see that they don't have the same index, so you can't multiply, okay? All right, here we have something that does have the same index, so we're going to multiply. All right, so I'm going to do the cubed root of 12 times 18, which is 216. Oh, there's one of those roots I've been talking about. So the cubed root of 16 would be 6. Okay, here's some examples with negatives. It's still, check your index. The index is the same. So this would be the cubed root of -64, which would be -4. Okay, all right, let's look at dividing, the properties of division. Oops, sorry about that. I jumped a page. Okay, so dividing. Now, I want to make sure you understand that when you're looking at roots like this one, this actually means the same thing as this. It's just written separately. But you could, if you want to consider it. Now, since they both have the same index, you can divide them. So, and they are both radicals, so you can divide them as well. So 2 goes into 18 9 times, so you can simplify. And then you can simplify with the properties of exponents. So x to the 5th over x cubed would give me x squared, so 9x squared. Now you can evaluate that. Remember, so we have the square root of 9, which is 3, but when we take the square root, it's an even exponent, and an even exponent here, we have to consider absolute value. Why? Well, because we don't know if x is a positive number or not. So we want to make sure that we have to recognize that it has to be positive. All right, so the same thing is true with cubed roots. Again, you can divide first. All right, so let me do that. 3 into 162. Is 54. Okay, so we've got the cubed root of 54 x cubed. Okay, so now I have to simplify that. So 54 is not a perfect cube, so I have to use some of the skills I learned in the previous days. The cubed root, I would probably see that the cubed root of 27 is a factor of 54, and it can be rewritten as the cubed root of 27 times the cubed root of 3, okay? And then I have x cubed still. So the cubed root of x cubed is x, right? And the cubed root of 27 is 3. So those are both now real numbers, and that cubed root of 3 would stay within the radical. All right, last one, 50 over x to this, or 50x to the 6, so the square root of 50x to the 6 over the square root of 2x squared is going to give me the square root of 25x to the 4th. So that would be 5 absolute value of x squared. Okay? Now, if you see in the question where it says assume all variables are positive, then you don't need to do absolute value. But if not, you have to do that. Okay? Last thing we need to talk about is rationalizing the denominator. So in previous classes, you knew that One thing about math, it's like a rule. I'm not even sure why we do it, but it's a rule in Algebra 2 that we never leave a radical in the denominator. So we have to rationalize. To do that, we need to make the bottom a real number. The only way to make the bottom a real number is to multiply to get rid of the radical. So to get rid of a 2, I actually have to multiply by root 2 over root 2, giving me root 2 over 2. Why? Well, root 2 times root 2 is 4, or root 2 times root 2 is root 2 squared. So that will give me that real number. So with cubed roots, you have to be a little careful because now you've got to make it a perfect cube. So in this case, I look at it, I'm going to evaluate first. I see that the cubed root of 8 is 2. So I don't have to rationalize. So I always want to check that first. Like that's step 1. I don't want to have to do this unless I absolutely have to, okay? All right, but looking at the second one, none of those are cubes. So you have to make them cubes. So I'm going to multiply here by, all right, let's think about this. 4 times 2 would give me the cubed root of 8. So I'm going to multiply by 2. Y squared, I'd need another y. And z, I would need 2 more z's to make that a perfect cube. And so I'm going to multiply that over itself. Why? I'm allowed to do that because it's the number 1. All right, now I'm going to multiply across, and that's going to give me the cubed root of 8, y cubed, z cubed. So that was my goal. I want a real number. I want this to evaluate to a real number in the bottom. And in the top, I would have then the cubed root of 10 x squared y z squared. Let me get that radical all the way over. Okay, now I can go a little bit farther. So that's going to give me the cubed root of 10 x squared y z squared all over 2y z. Okay, and there I have that real number in the bottom. All right, I'm going to stop there for today. Have a great day.